So before we go into logs, let's review what we know about exponential functions, okay? So let's say we have y equals a to the x. What is the domain here? For every exponential function, domain. All real numbers. Because remember, what are the two restrictions we have for domain? Yeah, if you have a rational function, so an x in the denominator, or the even root, the square root, fourth root, and so on. Okay, so those are the only two domains at this point that we've talked about that are even restricted. Every other function's all real numbers. How about the range? If we have y equals a to the x, so 2 to the x, 3 to the x, 4 to the x, what's the range going to be? 0 to infinity. Remember, we have our asymptote at y equals 0. And so since this is our parent function, it's going to be going up. What are our points going to be here? 0, 1, 1 base, -1, and reciprocal of the base. Okay, everybody good so far? Okay. Now, what you may or may not remember about log functions is that they are the inverse function of the exponential function. And anytime you want to find the inverse function, what do? For anything. To find an inverse function, good, you're going to switch the x and the y. So this means we have a to the y equals x. So I just switched, and anytime that you want to actually figure out the inverse, we need to solve for y. And the issue that we come up with here is that y is the exponent. So you guys probably learned some strategies for how to solve for y and how to switch forms. And some people, like, they have this system of how they move stuff. I don't really rely on that. What I rely on is just the basic terminology of the position of things here. So every time I have a to the y equals x or any exponent, I know it's always base to the exponent equals some number, right? This is a base because it has an exponent, so it's base to the exponent equals a number. Everybody good so far? Okay. Well, we're going to get into log notation, and it turns out that log, it's always log base of some number, and logs equal the exponent. This is what I know. Okay, so when I look at this, I say to myself, well, what is the base? The base is a. And what I know for logs is I know that it's log base a, and I know that logs equal exponents. Well, what's the exponent for this problem? Y. Well, logs equal exponents, so log has to be y. What's the only other number left over here? X. And this is the inverse function. So if I come up here, okay, then I'm going to say now for my log function, I know that y equals log base a of x. Okay, and these are inverse functions of each other. Here's what else I know. I know that I have a domain and range. And how did the domain and range relate to this one? Yeah, they're just switched, yeah. So this domain is now 0 to infinity, and the range is all real numbers. Instead of y equals 0, I now have x equals 0 because every x and y value switch. And instead of all these points, all I need to do is just flip them all. So instead of 0, 1, I have 1, 0. Instead of 1a, I have a, 1. Instead of -1, 1 over a, I have 1 over a, -1. Okay, so my suggestion to you guys, especially tomorrow when we get into graphing, is to always write the exponential ones first and even label it. Be like, all right, I know this is exponential, right? And always memorize these and use these and then write these as a side note, knowing that those are logs. That way you don't accidentally flip-flop them come test time or quiz time. Okay, so we already have this memorized, but then you know this is everything just flipped. So still just memorize exponential and use the exponential always as a reference. Like, take the time to like have both available and write this first and then write that as needed. Okay, so this is the thing that I'm going to focus on now. for the next step is this kind of switching between the two forms. So if we go to this first example here, okay, I always ask myself the same questions. No matter which way I'm going, the questions I ask are, what is the base, what is the exponent? That's what I ask myself over and over. So for this one, what is the base? So I'm going to put log base 1.2, and I know that logs equal exponents. So I put an equal sign, and for this particular exponential expression, what is the exponent? 3, and then what's the only other number left? And then you put that guy here. Easy peasy, right? Now we can go the other way too. So here I'm starting with log, and I want to change it to exponential. So I ask myself the same questions. For this, what is the base? The base is a. What is the exponent? Because logs equal exponents, and what's the only other number left? 4. What is the base? What is the exponent? That's 2 questions to switch from forms that are going to help you out. So we go to B here, and here what is the base? E. So I have log base E. What is the exponent? What is the exponent in here? B, and the only other number left? 9. All right. Log base E, does anybody know how we can actually rewrite that? ln, natural logarithm. This is also natural log of 9 equals B. These are identical statements. All right, same thing. Okay, there are 2 logs where we don't write the base. We don't have to. You can. All right, and the 2 bases are base E, that's your natural log, and then base 10 is your common log. And you'll notice on your calculator, those are the 2 buttons that you actually have on your calculator because those are the most common logs that we use. Okay, what is the base here? So we have log base A. Logs equal the exponent. What's the exponent here? And the only other number? 24. What's the base here? 10. This is where, again, if the base isn't listed, it's either got to be E or 10, and you know it's E if it is a natural log, ln. Okay, so here the base is 10. What is the exponent? -8, because logs equal exponents. So we have 10 to the -8 equals the only other number left, D. Okay. For C here, it kind of goes ahead and shows you the 2 situations. These 2 are the same thing. We have log base E of B, and we have natural log of B. These are the same exact thing. So when you see just this statement, you need to know that the base there is E. All right, so the base is E. What is the exponent? -3, and then the only other number, B. And then the last one, what's the base? What's the exponent? Equals the only other number, 5.